Hi everyone. This is an example of a mass-to-mass stoichiometry problem. Here we go. When 15.0 grams of sodium chloride react completely with lead 2 nitrate, what mass of precipitate is produced? This is a mass-to-mass question because it starts with mass of one chemical. We're looking for the mass of another chemical. This is also an example of a question that asks us about the precipitate, which, as you might recall, is the solid product. When we have a stoichiometry problem, we're always following these 4 steps, the first of which is to balance the equation and interpret the question. We might be on the lookout for some keywords. We're going to have sodium chloride reacting with lead 2 nitrate. And we have this expectation that a solid product is going to be produced. Here we go. Sodium chloride, you know it. Sodium 1 plus, chloride 1 minus, react with lead 2 nitrate. Lead with a 2, Roman numeral 2, means the charge is 2, and nitrate is a 1 minus. So this is a double replacement reaction. The lead 2 and the sodium exchanging spots, the cations exchanging spots. And the sodium is 1 plus, the nitrate 1 minus. We need to balance this equation. When we do that, we have 2 sodiums on either side, 2 chlorides on either side, 1 lead, and 2 nitrates, a balanced equation. Let's get to work with the interpretation. 15.0 grams of sodium chloride. Here's the sodium chloride. It's the mass. 15.0 grams. That number was provided to me in the question. This is the given. We have some work to decide what we're solving for. What mass of precipitate is produced? One of these 2 products must be a solid. The precipitate, by definition, is the solid product. To answer that, you need to go to the data booklet and check out the solubility table to make that decision. Here it turns out that the lead 2 chloride is the precipitate. Takes a little bit of work, and it's in an indirect way, but the question is asking us, what's the mass of the lead 2 chloride? Because it is a solid. When we check the solubility table, sodium nitrate is aqueous, it's highly soluble, and the lead 2 chloride is a solid. It has a low solubility. It is the precipitate. This is a mass-to-mass gravimetric stoichiometry problem. Our next step, find moles. The question didn't tell us we can't find moles just by reading. We have to do mass over molar mass. We have the mass of sodium chloride, so you must use the molar mass of sodium chloride as well. This is the mass, 15.0 grams of sodium chloride. We need to use the molar mass of NaCl. Sodium is 22.99, chlorine 35.45. Molar mass of sodium chloride is 58.44 grams per mole. After we find the moles, our next step is to multiply by R over G. Here we're going to multiply by, I didn't write it. Wherever that question mark is the R. This is R over G. Here we have a 1 over 2. 1 over 2. All of that represents what I call the red N. Any work we did before and the R over G together collectively make the N. Or, after we multiply by R over G, what we have is the red N. Here we're looking for the mass, so it's this red N multiplied by the molar mass. We have the moles of the lead 2 chloride, so we multiply by its molar mass. Now lead is 207.2, and we have 2 chlorines, 35.45 each. The molar mass of the PbCl2 is 278.10. Now we have some buttons to push. 15 over 58.44 times by a half times by 278.10. We end up at 35.6904517.5. The question has one number in it. It has 3 significant digits. We need to round this off. 35.7, and we found the mass. When questions ask us for the precipitate, that's an indirect way of saying, what's the mass of the solid? We had to check the solubility table in the data booklet to decide that this one, PbCl2, was the precipitate. From there, we used mass over molar mass twice with a different molar mass each time. Because we had the 15 grams of the NaCl, we used the molar mass of the NaCl, the given. After the R over G, we used the molar mass of the PbCl2. To find the mass of the lead 2 chloride, we had to use its molar mass. And I hope that helps.